actually show that the activity was due to the triketones. All of the activity of the whole oil can be extracted in a concentrated oil fraction containing nearly pure triketones. Activity was reduced to the level of a non-triketone containing hematite once this was removed. So here we have a very low figure here and a very low figure here, which is what we're looking at. So we've got the whole oil and the triketone concentrate. When it was removed, the figure goes up to 1.25. Let's take a look at some results. The following overhead shows these results both in figure and in graph form. Again, we're looking at the minimum amount required to inhibit activity. These figures are for gram-positive bacteria. I want you to notice particularly the Staph aureus, Staphylococcus aureus, the MRSA, and also the Listeria. And you see here the comparisons with Manuka and Australian tea tree and pine. What this means is, what does it mean to us as an aromatherapist? Well, the clinical application, when you look at particularly Staph aureus and epidermidis, are things like cellulitis, carbuncles, impetigo, ear infections, pneumonia, septicemia, and sinusitis. Listeria is particularly important. It is one of the agents involved in meningitis. Here are the same results in graph form. So you can see how well Manuka performed. And again, Listeria is here. Let's look at the results for gram-negative fungi and yeast. What I think is particularly interesting here is the results for Candida. Here's Manuka, Manuka, Australian tea tree, and pine. Actually, we can see pine did pretty well here. And this test was done on Pinus sylvestris. Again, just looking at it in graph form, we can see that pine definitely performed better, but Manuka did pretty well. Australian tea tree is up here. So again, we're looking at the minimum amount. Manuka's activity against fungi is also of interest. This graph, I want you to notice the mentagraphites, the rubrum, and the canis. So we're looking at these in comparison to this. These fungi are all responsible for various types of ringworm. Again, remember that any scientific evaluation of Manuka must determine the chemotype and the triketone concentration. A 1996 paper by Liz Belchin and others states, and I quote, Manuka unfortunately showed variable antibacterial activity between samples. With its moderately low antifungal action, it could not be recommended as a universal antibiotic. There is no justification for promoting the antimicrobial usage of either Manuka or Manuka. The antimicrobial activity of Manuka in the present studies contrasts with those of Cook and Cook in their action against the bacteria studied. End quote. Unfortunately, this paper failed to state the chemotype or source of the oil, which may explain the poor results compared to the studies I've just shown you. In addition, what I thought was interesting was this paper used to determine the antibacterial activity. It relied on the solubility of Manuka in agar. Solubility has been shown to vary between oils, and in fact Manuka has quite poor solubility. So this is a really important point. The agar method is generally used only to indicate whether or not any activity exists. if you want to determine the actual level of activity, a nutrient broth system is best, such as that used by Cook and Cook, which a lot of the results I've shown you were based on. Let's get back to how triketones work. Do we know? In a number of conversations with Nigel Perry, author of many of the research papers I've quoted here, he commented, and I quote, "I think it would be fair to say that the mode of action is not understood," end quote. Roche Lab in the UK did some work on triketones, but the lab and the research team have since been dispersed. Lloyd and others tested a number of cyclohexane triads, which is on the next and last over here, and I know I'm running out of time. What was interesting about these is they had a marked similarity to the triketones in Manuka. The major difference is these side chains. But what they were able to show was the minimum inhibitory concentration of the trans was weaker than Manuka, but they were able to show the activity was not due to lysis, which is rupture or disintegration of the cell membrane, or the effects on the permeability of cell walls in gram-positive bacteria, that they actually appear to work by reducing the rate of transport of small molecules across the membrane. The inhibitory effect on bacterial cell membrane systems is similar, actually, to bacterial growth inhibitors. But because triketones are equally effective against antibiotic-resistant strains, they must have something different about their mode of action. This is what we still do not know. So our research is working on this. Well, New Zealand is where most of the research is currently being done, although I do believe there are clinical trials being conducted in Britain. If anybody knows about this, I'll be really interested to hear about it. What are the achievements so far? A selection program which maximises the triketone content in oil yields. Improvement in the extraction process, so distillation has improved and the cost is going down. Work continues into the triketone chemistry and the biosynthetic pathways to explain how these plants synthesize and accumulate these unusual compounds. The triketones have been synthesized in vitro with pure compounds, and work is being done on comparing the physical, chemical, and activity characteristics of the triketones. Research is also being done to compare the oil to Bactroban as a standard control agent for Staphylococcus aureus. Funding is an issue. In closing, where Manuka really stands out, specifically the high triketone East Cape chemotype, is in the activity against gram-positive bacteria. In these days of increasing resistance to antibiotics, the activity against MRSA is most significant. The research makes it obvious, as with any infection, it's really important to identify the bacteria before you treat with essential oils or antibiotics. That just makes sense. The research outlined on the overhead shows powerful activity against very specific bacteria and fungi, with MIC values ranging from 0.020 to 0.156. Activity against herpes simplex, polioviruses, and tumour cell lines have also been identified by Perry. The most important thing to remember from this presentation is that not all Manuka oils are created equal. There are at least 3 chemotypes and only one containing triketones. Triketones are considered to be the major contributor to Manuka's activity. I would really recommend anyone using essential oils clinically investigate using Manuka. Thank you for your attention.